Hello students, welcome back. So now we are going to talk about the hardware implementation, and the hardware implementation is done using the FPGA boards. So you may have a lot of questions. So in this video we are going to talk about that what is an FPGA, difference between a CPU and the FPGA, what is inside the FPGA board, and how do we program it. So first of all, the question that we have is what exactly is an FPGA? FPGA stands for Field Programmable Gate Array. These are the circuits that can be configured to act like any other circuit. That means I have a board with me, and according to my program I can convert it into any circuit's functionality. You can do a lot of things, but in the FPGA the main focus is on the reconfigurability. That means today I am using this FPGA board to make one smart traffic light system. Next day I can make it only a simple 4-bit adder. So these are the things that we can do. We can reconfigure. FPGAs perform much faster than the CPU for the dedicated task. So let us understand the difference between a CPU and the FPGA. A CPU is basically a chip which is designed to execute a fixed and specific set of instructions in a sequential manner. On the other hand, FPGA is also a chip, but it is having a series of logic blocks, and we can modify them, reconfigure them, reconnect them as per the requirement. In the CPU, the hardware is fixed, whereas in FPGA, the hardware components can be reconfigured as per the user requirement. What are these reconfigurations? We will discuss these in our training when we talk about the FPGA implementation in detail. In CPU, the design is for the general purpose task, like you have a microprocessor which is controlling your computer, your personal computer, right? Whereas in FPGA we design very specific circuits like a license plate recognition system. In CPU, because the production is at mass scale, the price is low, whereas FPGAs are not so commonly used, so they are slightly expensive, and FPGAs are designed in different models. That is the reason that they are expensive in cost, but they are very high computational devices. So how are the FPGAs different from ASICs? Now, ASIC is application specific integrated circuit. It is not the microprocessor, but imagine that you have a toy which is going to take some inputs from the user and process the data, and the drone will fly and capture the video and send it to you. So for that we design only one dedicated chip, and that is called application specific integrated circuit. Now these are special chips which are built only for one application. So if I have a chip for a drone, it will work only for that drone, only for that model. A few more examples are Bitcoin miner, Intel Neural Network Accelerator, and so on. These functions cannot be changed once they are built. And on the other hand, FPGAs can be programmed. We can reconfigure them. Functions can be completely changed. So today my FPGA is working like the Bitcoin miner. Tomorrow I can reconfigure it to control a drone. FPGA fabric will emulate these custom circuits. So that is the huge advantage that we get with FPGAs, and our training will focus on the FPGA based system design. So let us talk about that what is inside the FPGA which is making it so useful. So the basic architecture of FPGA is, you can see there are so many square blocks, and then in between all these square blocks we have some interconnect lines, and on the either sides of the FPGA we have input output ports. So if we look at the square box, then inside the square box, which we call as the programmable unit, we have lookup tables, we have latches and flip-flops. The lookup tables are inside the configurable logic blocks. In short, we call them CLB. So this is where you can change the circuit. It can take 6 inputs or 8 inputs based on the type of FPGA you take. The logic is computed inside the CLB, and if we need memory, we use flip-flop and latches. So that is the sequential circuit, and the whole thing is one CLB block. One FPGA is having thousands and even sometimes millions of these CLBs. So if I have 2 inputs, one of the CLB will be used and the data will be processed, output will be computed, and the output is given to one of the output ports. This is how we reconfigure the FPGA. In this example, we are using only one CLB. Based on the complexity of your code, more than one and more than thousands of CLBs can also be used. So let us take an example of the easiest CLB that we can have, that we have shown in the previous example. That was the CLB computing the functionality of 2 input AND gate. So basically, out of all possible logic gates which were available inside the CLB, we used only one AND gate. We took 2 inputs and we decided that when both the inputs are 1, the output will be 1, otherwise the output will be 0, and the output is connected to the output port. The next type of blocks that we have inside the FPGA are the DSP blocks. Again, they are arranged in the same fashion that we had for CLBs, connected with interconnects and the input output ports. The main purpose of these DSP blocks is to provide arithmetic function support. So inside these square blocks we have the arithmetic operation which are available. So DSP blocks will provide the functionality like addition, subtraction and multiplication. So inside the DSP block, multiplier, adders and subtractors, everything is available. As per the requirement, we will use them. The next type of elements that are available inside the FPGA are the RAM. That means the memory elements. So they are also arranged in a very similar fashion. So here we use the flip-flops. The CLB can act as a flip-flop as well. Some of the on-chip static RAM provide us these blocks. These can be very small in size, like 18 or 36 kilobits. It can be in the megabits also, and you can also have massively parallel access in terabyte per second also. So as per the requirement, the FPGA board will have the memory in KBs or MBs or even higher. So that completely depend on the application for which you are using the FPGA. Typically for the low end FPGAs, the memory is in few kilobits. Do not worry, that is more than enough for the purpose of our circuit design.
Now
we are going to talk about the FPGA board that we will use in our training program. We are going to use Basis 3 board. This is a board which is designed by Digilent in association with Xilinx. This board is having 33,000 plus logic cells in 5,200 slices. This board is having 1.8 megabits or 1800 kilobits of RAM. There are 90 DSP slices. We have our internal clock which can support the clock speed of up to 450 MHz. There are 16 switches and 16 LEDs on the board. We also have 5 push buttons. We have 7 segment displays and there are 4 7 segment displays on the board. There are P mode connectors and a VGA output port as well. This board is quite versatile and best suited for the beginners to design digital systems. In addition to all these, we also have the support for serial flash. That means through the USB we can program this FPGA. Now we are going to have a look at some other FPGAs that are used for different purposes. We have FPGAs which can be inserted inside your CPU. We have the FPGAs which are mainly for storage purpose. So some FPGAs can be attached to your PCI. Some of them are directly attached on the memory card. Some FPGAs are inside the processor itself. So Intel Xeon processor is having the Intel Aria FPGA system on chip, and there are FPGAs which are mainly designed for networking applications. So there is a huge variety of FPGAs. Once you understand one of them, you will get the basic idea that how to work with FPGAs. And the reason we have chosen Xibo because it is a simple board and the best suited one for the beginners. So students, now that we know about different FPGAs and their applications, let us check them out in real world, that how do they look like and what are the features available on every board. Keep learning. Thank you.